All right? We are about to pull back the curtain on the real magic behind the AI you use every single day. We're going to demystify the one core idea that lets these machines understand language the way we do. Let's dive in.
So we all use tools like ChatGPT, right? But have you ever actually stopped to wonder what's going on under the hood? What's the secret engine in there that makes it feel so, well, so human and how it gets what you're saying?
Well, it's kind of like a set of nesting dolls. The big outer doll is generative AI. You open that up, and inside you find the architecture that powers it all, something called transformers. But if you open that up, you get to the very, very center, the real breakthrough, and that's a mechanism called self-attention. That's the secret sauce, and believe it or not, we're going to invent it together, right now from scratch.
Now, to really get why self-attention is such a game changer, we first have to understand the problem it was designed to fix. And it's a problem that's super simple for us, but for a computer, it's a massive headache. That problem is understanding context.
Okay, before we go any further, there's one quick concept we need to nail down. See, computers don't speak English, they speak math. So to process language, the very first thing they have to do is turn words into numbers. The standard way to do this is with something called a word embedding. Just think of it as a long list of numbers, a vector, that acts like a digital fingerprint for a word's meaning.
And this right here perfectly illustrates the problem. Look at the word bank. In the phrase money bank, it's about finance. In riverbank, it's about, well, the side of a river. For us, those are two totally different things. But with these traditional word embeddings, no. The computer sees the word bank and it assigns the exact same list of numbers in both cases. It's completely blind to the context around it. So you can see the issue, right? These static, one-size-fits-all definitions for words are a huge limitation. They just don't work. What we really desperately need is a way to create dynamic meanings, embeddings that can actually change and adapt based on the other words in the sentence.
Okay, so how do we do that? Well, you know what? Let's just try to invent the solution ourselves, starting from the very basics. This is where things get really fun. Let's just ask a simple question. If we know a word's meaning is shaped by the words around it, its context, then how could we literally make a word's new meaning out of its neighbors?
And here it is. This is the big aha moment. A beautifully simple idea. What if the new contextual meaning of bank wasn't just the dictionary definition of bank? What if it was a cocktail, a mix? Maybe it's, say, 70% of its original meaning blended with 25% of the meaning of money and 5% of grows. You're literally creating a new meaning by mixing in the flavors of the words around it.
We can translate that intuitive idea into something a computer can understand. This mix is really just what's called a weighted average. All we're doing is taking the number lists, the embeddings for every word in the sentence, deciding how important each one is, that's the weight, and then just blending them all together.
But that leaves us with a really big question, right? How do we calculate those weights? How does the machine know that in the phrase money bank, the word money is way more important for defining bank than the word grows? Okay, let's build the little machine that figures this out.
The main tool we're going to use is a simple math operation called the dot product. Now don't let the name scare you. All you need to know is that it takes two vectors, or two lists of numbers, and it just spits out a single number that tells you how similar they are. That's it. A higher number means they're more related. So, step one is pretty straightforward. We take our target word, bank, and we use the dot product to measure its similarity to every other word in the sentence, including itself. This gives us a raw similarity score for each pairing. So S21 is how similar bank is to money, S22 is how similar bank is to itself, and so on. The thing is, these raw scores are, well, they're a mess. They can be any number, big, small, positive, negative. They're not those nice, clean percentages we were talking about. We need a way to clean them up, to normalize them into proper weights that all add up perfectly to 1 or 100%.
And for that, we use this super handy function called softmax. Honestly, just think of it as a little normalization machine. You feed your messy raw scores in one end, and out the other side pops this beautiful, clean set of weights. They're all numbers between 0 and 1, and they all add up perfectly to 1. It's exactly what we need. And now we're at the final step, the mix. We take our new, clean weights and we multiply each one by the original embedding for its word. Then we just add all of those results together. And what do we get? A brand new vector,
a new embedding for bank that's now completely infused with the context from the words money and grows. It's a dynamic meaning.
So we just walked through that logical three-step process for a single word. But what makes this so incredibly powerful is that this entire process can be boiled down and formalized into a single elegant equation. And it gets even better. We don't have to do this one word at a time. Using some clever matrix math, we can run this entire three-step calculation for every single word in the sentence all at once, in parallel. This is what makes the whole mechanism ridiculously fast and efficient.
And there it is, the famous self-attention formula. I know, it might look a little intimidating at first, but you know what's going on in there now? It's not magic. It's just a neat mathematical summary of the exact intuitive process we just built from the ground up. Calculate similarity, clean it up with softmax, and then create the final weighted mix. That's all it is.
You know, the whole goal was to make you feel like you could have invented this yourself. And if this idea that sounded so complex a few minutes ago now just feels logical and simple, then our job here is done. Because this ability, this idea for AI to dynamically understand context, it wasn't just a small improvement. It was the fundamental breakthrough. It was the key that unlocked all the powerful AI tools we use every single day. Which of course begs the question, now that this door has been kicked wide open, what comes next?